Then we have the op-amp voltage of an integrated circuit op-amp will clip if our load resistance gets too large. So if we are to draw out our op-amp, it's going to look like this. We know we have two input terminals, and for this one I'm going to draw the power supplies. So we have a negative and a positive right here, and then we also have our V output. Now it's asking us if the output voltage, or V out, of our circuit op-amp will clip if our load resistance is too large. And well, if load resistance is too large, it's basically going to limit some of the voltage that goes into our op-amp. But this isn't a problem. So it's not going to clip if our load resistance is too large. It's just not going to be letting a lot of voltage in. Now, what causes clipping is not the load resistance getting too large, so this is false. What causes clipping is the output voltage being greater than our powering voltages. So, for example, if we know we have a 13 volt power supply, so we have minus 13 volts and plus 13 volts, that means our V out, if it's greater than 13 volts, so like let's say it's 15 volts, that means it can't be 15 volts. The max it'll be is 13 volts, around there, because we have some room for error and we lose some voltage. But ideal op-amp is about 13 volts. Clipping can also occur if the op-amp's output current, which is I naught, needs to be larger than the max to reach the desired V out. And this is because our V out is equal to our IL times RL, which is the last load, or the resistance right here. And we know that IL times RL is equal to V out, so if we multiply our IL and our RL and we get our V out to be bigger, we can see that we have a problem here. But that is how we would look at clipping with our op-amps.